Let me start with, I'm not a global platform expert, right? Even though I talk about it here, it is a topic that has been, global platform existed for a very long time, for decades. I only have seen certain parts of it, and those parts mostly that relate to the SIM cards and the telecom part. This talk is not particular for the people watching recording or something. This is not about basics about USIM or SIM technology, or even basics about eUICC. There are all kinds of talks that you can find on that topic on Media CCCDE that I've given over the last couple of years. So I will not repeat that here. Just a little bit of refresher on terminology to make that a bit clear. So we have classic SIM cards, which are so-called single application smart cards. So it's a smart card that only has a single purpose, which was the subscriber identity module function in a classic GSM phone. Then before UMTS came out, and in UMTS, as we know, everything became universal. That's what the U means. They also specified the universal integrated circuit card. So it is a multi-application platform for smart cards. This was specified in ETSI. And the USIM, the UMTS subscriber identity module, is an application on a UICC. So with the classic SIM card, it was basically one spec that covered everything from mechanical, physical, electrical, protocol, layer 2, layer 3, application, everything basically. And now we have a specification that covers the UICC, which basically covers the operating system and the file system and some common functionalities. And then on top of that, we have applications. And the application relevant for 3G, 4G, 5G authentication is called the USIM application. And then later on, we got another application, the so-called ISIM application, which is an optional additional application that can be used for IMS authentication, so in the context of VoLTE and voice over Wi-Fi. There are, of course, other applications, but I just wanted to clarify this, like single application versus multiple application smart card. An eUICC now is an embedded UICC. So in a specific meaning that it has, this term has received in the eSIM universe, it is sort of the physical part, the physical chip that can host virtualized SIM cards, which are called eSIM profiles. So we have, first we go from single to multi-application smart card, and then we have sort of virtualized smart card applications inside a physical chip. So that's sort of the evolution that we have there. So when I talk about the physical device, I'm always talking about the eUICC. And when I say eSIM or eSIM profile, I'm talking about the virtual logical function of a subscriber identity module that gets installed on this physical chip. Some other people use the terminology differently, but I find it highly confusing to say eSIM for the physical device, which is sort of very ambiguous what eSIM is then in this context. So, but now here we focus on global platform in this talk. Now what is global platform? Strictly speaking, if you really look for the definition, it is what they self-describe as a consensus-driven technical standards organization. So if you say, well, does this card support global platform, then it's actually completely wrong, because it's like, well, does this network support 3GPP? It's like, oh, yeah, well, doesn't really make sense. So what people mean when they say global platform is actually, they mean the global platform card specification, or short GPCS. And that is a document that has gone through many revisions over decades, with lots of annexes and corrigendums and whatnot associated with it. That is actually the specification. So if people say, well, is there global platform support, they refer to the global platform card specification, which is only one of many different specs that global platform as the organization specifies. So it's a bit weird. The history of this is that actually I think Visa and some other, well, I think it was only Visa in the beginning. So the payment industry wanted to specify, let's say, a common architecture for cryptographic smart cards, so they could focus on the application of their payment system running on various smart cards from various vendors, and to have some kind of interoperability and multiple sourcing and so on. That's actually the history of this. And then more payment industry, and then this also later on the telecom industry realized that they can use this. And there's not really any other, not that I'm aware of, any other multi-vendor, widespread use sort of specification on how different smart cards from different vendors. You could say it's like the POSIX for Unix-like operating systems is a global platform for smart cards. It doesn't specify a concrete implementation, but it specifies sort of an architecture and some common interfaces and some, let's say, some syscalls or something like that. So a global platform capable card, or more specifically, a global platform card specification compatible card, is now a multi-application smart card that typically supports on-card cryptographic operations and cryptographic authentication of external users, and the installation of on-card applications from off-card sources via secure channels. So that's sort of what it covers in a nutshell, right? So we want to be able that some external entity that can be, traditionally it's maybe the operator of an application. Let's say you're operating a payment system, and then you install an application on a smart card, and then you want to remotely interact securely with the smart card, and you want to exchange information with it, and maybe you want to update the software in it and that kind of stuff. And that's what Global Platform is about. So this is the, I think, very bad diagram from the spec. This is the architecture diagram. I'm like, yeah. As you know, I don't really do many graphical representations in my slides, and this is sort of, I think, an explanation why it's not always a good idea to have graphical explanations. But they like these three-dimensional blocks, and they have this several times in the spec. But in the end, I mean, what you can get from this is that there's basically something below Global Platform, which is the runtime environment, which is your actual card operating system. In reality, it most often is a Java card, but Global Platform doesn't actually mandate that. So it doesn't really specify what it is, any specific operating system or any specific language or something like this. And then we have something called the open, and I have never and it's always written all uppercase, so it looks like an acronym, but I've never even seen a definition of what this acronym means anywhere in the specs. So it's always the open, and the open is a part of this infrastructure, which is sort of the entity that you talk to, which dispatches APDU commands inside the Global Platform card. So it's something on the card, and that's called the open. Okay, so, and then we have on the card, we have so-called security domains. But before we go in security domains, let's talk about applications. I mean, I said it's a multi-application smart card, and what is an application? Well, it's code that you can run on a smart card. The functionality depends, on the application, pun intended. If you interact with smart cards, there's the concept of a currently selected application. So when you talk to a card, in a classic SIM card, you cannot select applications, you can only select files, and then you read and write a file. But in a Global Platform card, you can select an application, and then this application sort of is the application you're talking to. Like you're opening a channel to that application, and then almost any commands you send to the card actually get dispatched to this application that you have selected. So an application can register a callback for receiving incoming APDUs if it is currently selected. And the selection works by AID, that's the application ID, which is just a hexadecimal string, and it's allocated a bit like MAC addresses or something, so you have a prefix and you can get a prefix as a company or organization. I think Sysmocom even got one many years ago when we were supposedly doing a project that required it, but then never did it. So this is called the RID, the Registered Application Provider Identifier, and then the remainder is the PIX, the Proprietary Application Identifier. Not sure how that X comes into that. And this is how they explain the acronyms in the spec. It's like, I don't find an X in anyway. AIDs are well known, so in the sense that if you are a phone and you want to talk to the USIM application on a card, the 3GPP specification says, well, the USIM application uses this AID, or this AID prefix at least. There can be a remainder that changes based on the vendor, but there's a certain prefix. And so this prefix is what the phone operating system uses to say, well, I want to talk to the USIM now, or I want to talk to the eSIM now. This is how this works. Now, what are security domains? That's something that you see a lot in the context of GlobalPlatform smart cards. For me, it took quite a long time to really get an idea what this is. I mean, I always read it, but it was sort of not really graspable because it's so different from what we see in normal operating systems on other systems that are not smart cards. So a security domain technically is a privileged application, meaning that it's an application that has certain permissions or certain, you could think of, let's say, capability, a process that has capabilities on Linux or something like that. And it represents an on-card representation of an off-card entity. So let's say you're Visa or MasterCard or something like that, or an operator for that matter, a cellular operator, that is an off-card entity. It doesn't live on the card, but it has something on the card, and it has something on the card that represents its security domain. So anything that relates to its application or multiple applications, but it's sort of a container or something on the card that is isolated from all the other security domains on the card. And sort of the operating system and the common criteria certification or EAL or whatever certification of the card, the security target basically says that one security domain may not ever see anything in another security domain, and there's no way how they can interact apart from some certain very specific APIs with cryptographic authentication and so on. So it's like a container in there. And what you always have on a card is the issuer security domain, the ISD, not to be confused with ISDN. It's mandatory primary, sort of the root container on the card. And it typically represents somebody called the card administrator, which is typically the card issuer. So if you look at the eSIM or eUICC example, the company that manufactures the eUICC is sort of the card issuer, and they have authority and control over the issuer security domain on that card. And what that means in practice is that they have key material that allows them to authenticate against that ISD and then to install additional stuff or delete stuff or do whatever with the content of the issuer security domain. And then you can have supplementary security domains, SSDs, not to be confused with solid state drives, which are additional and optional, which the name supplementary sort of implies. And those are additional application providers or the card issuer or agents authorized by them. So let's say I'm a card issuer and I want to authorize some other organization to also have a security domain on the card where they can do whatever, like say public transport functionality on a credit card or some contrived example. Then you can have a supplementary security domain for the public transport authority, and they then have key material to talk to that particular domain, and they can do whatever they want in that domain, but as long as the security target holds true, not leave that. And then there is something called the controlling authority security domain, which are special supplementary security domains, which are independent from the card issuer and the application providers, but responsible for enforcing specific off-card or on-card security policies. So in eUICCs, we have something called the ECASD, the eUICC Controlling Authority Security Domain. And that is basically where the root certificate is stored from the GSMA normally. Sort of this ECASD then has the responsibility to authenticate anyone who might ever talk to it, so that they basically present a certificate that is derived from this root of trust. No matter where that is. So the security domains, as they are special applications, they also have AIDs, and then they hold cryptographic key material for so-called secure channel protocols, which are, your VPN in quotes or whatever, your TLS or whatever you want to call it. So some kind of transport protocol to cryptographically talk to the smart card. and to also authorize card content management, which means, authorize installation and removal of applications and stuff like that. The security domains are isolated, as I already mentioned, and a security domain normally has, but it may have applications associated with it, and it may have executable load files associated with it. I'm not going into details of that, but basically, the idea is that, do I have a slide on it? No, I don't think. Oh, yeah, demo, shit, I should have prepared that. Yeah, my backpack is there, I have some cards in there, but okay. If executable load files is basically, well, it's some kind of object file or whatever you can install on the card, and then it's sort of, let's say, if you look at it in the Unix analogy, it's like the executable program that you put on a drive somewhere, but it doesn't mean the program is running. And then you can instantiate this executable load file, and that can create applications. So you can have two applications which share the exact same code, but you can have two instances of that with different privileges or whatever. So that's the difference between application and executable load file. And also, executable load files can also contain just libraries which are not standalone applications, but things that other applications actually use. So there's this kind of abstraction. Yeah. Question from Pau, I will repeat it. Yeah.
The AID is there for it changes for each instance, or it's just like the application package?
You have the AID of the executable load file, and then each instance has a different AID. So all of them have an AID, but they're in one flat AID namespace. So if you just look at the AID, you cannot tell whether it's the AID of an executable load file or of a security domain or of an application. But yeah, it's basically that. So yeah, I had this, I think it makes sense to go through the presentation and then go back to the demos, because if I now start to set up the card reader and so on, I guess it will, sorry for that, I didn't remember that. So yeah, now we have this runtime environment, as I already mentioned. How are we doing in time? Okay. That is provided by the card operating system, and GlobalPlatform, as that doesn't mandate a specific runtime environment. Usually it's a Java card. They also specify it for Multos, which is a non-Java card operating system. But yeah, as I said, in reality, and particularly in the telecom domain, it's always, I've never seen anything else but Java. So now, secure communication. I said there are these SCPs, the secure channel protocols. They allow an off-card entity to talk to an on-card entity in a secure way. Secure means either or integrity protection or encryption or combinations thereof, right? So you have basically authentication, integrity protection, and confidentiality, and this is like a bit mask. So you can select which of those you want to have. You know, for some use cases it may be sufficient to have integrity protection. Some others may also need confidentiality. Authentication, I guess you always want, otherwise it doesn't make sense. The most relevant global platform own, and we will have some more about the over-the-air stuff, but the most relevant SCPs in telecom cards, the classic ones are SCP02 and SCP03. Those are what I would call local secure channel protocols. So those are typically spoken between something that is next to the card or something where you insert the card into and the card itself. It's not a protocol that's by itself normally spoken over a wide area network or something. There are different SCPs for these use cases. So if, let's say, you have a Sysmo USIM and you plug that into your machine and you use GlobalPlatform Pro to install a RRM applet or some other a Java applet, then actually GlobalPlatform Pro, which is a software you run on your laptop, is establishing an SCP02 secure channel to the card using a PCSC driver, and then, or rather to the issuer security domain of the card, and then it installs additional executable load files and creates an instance. It's called the install for install. Yeah, you have install for load, and you also have install for install. I mean, what a great name. Yeah, so this is an overview of those SCPs. SCP-01, I never looked at it. It's so ancient that not even the Telecom, which lags decades behind what GlobalPlatform recent specifications are doing, is using anymore. So I don't know what they did. SCP-02 is triple DES, so it must have been something weaker than triple DES, I suppose. I don't know what that means. SCP-03 is almost like SCP-02, but it allows AES-based encryption. It's so in the parentheses the specification reference. So the GlobalPlatform card specification version 3 amendment D specifies SCP-03. That is what modern Telecom SIM cards or eUICCs speak. So this is sort of the secure default today in the Telecom world, I would say. SCP-02 is really ancient already. Then we have SCP-11, which is for elliptic curve and certificate-based authentication, which is specified in Amendment F. It's used in the eSIM universe. And then we have two SCPs with 8 in the beginning. Those are the ones that are implemented remotely over a wide area network. So I will talk about this in the OTA talk. So SCP-80 is basically what GlobalPlatform calls the normal OTA mechanism that uses SMS or cell broadcast or USSD to talk to an on-card application. And SCP-81 is HTTP TLS PSK based, which, as I also cover there. And you cannot read the remote, but yeah, it's sort of obvious what it means. Now, if we have multiple applications on a card, but we can only select one of them, it becomes a bit difficult if we concurrently want to access multiple applications on a card, right? So if you have a USIM application and an ISIM application, and we need both if we want to if an ISIM is present on the card, then both need to be used by the modem to establish a VoLTE, because it first needs the USIM to, let's say, authenticate on the EPC, on the access network, basically, and then it needs the ISIM application to authenticate against the IMS core on top of it. The way how this is done is by so-called logical channels. So normally when you talk to a smart card, you just send commands, and basically it's a one-to-one, point-to-point connection, and you cannot really have multiple sessions in parallel. But with logical channels, you can basically have multiple concurrent sessions between off-card entities and on-card entities that have their own state. So which file is selected or which application is selected, that's then state, that's not global, but it's per logical channel. And the basic logical channel is used to open and close. So you can basically send a command to the so-called basic logical channel, which is the one that you implicitly have when you talk to the card. You can send a managed channel command, and that managed channel command has different flavors like open or close or things like that. And now what you can do is basically you can establish different logical channels to a card, and you can establish different SCPs on different logical channels, which means you have different cryptographically secured ways how different off-card entities can talk to different on-card entities. So yeah, demo again later. What we also have is the so-called GlobalPlatform registry, which is an on-card information base that stores so-called card management information with like serial numbers and what kind of image and identifier of the card issuer and things like that. Application management information, which is sort of which applications are installed on the card, the life cycle state. So in smart cards, the life cycle is something that you have everywhere. The card has a global life cycle. Each file has a life cycle. Each application has a life cycle. Each is your security domain, and so on. And life cycle means sort of are we currently, for example, in personalization stage? That is initially when the card is being produced, where no security checks are performed and all the stuff gets installed on the card first. And then the life cycle gets changed from personalization to production, basically, or to operational, I think is how it's called. And then once this is a one-way transition, and after you've transitioned the card life cycle into that state, you cannot, basically all the security checks and everything that you've configured become active at that point. You can also terminate a card or terminate a file or terminate an application, and you can even do that in a final way. So there is a way how you can basically brick every smart card, which is if you have the necessary credentials, you can authenticate and you can say terminate card usage, and then the card is basically dead. you cannot use it for anything anymore. So that's what the life cycle means. And then we have resource management, like memory allocation and all kinds of other resources, like how many logical channels are available, things like that, that all is in there. So yeah, actually here I have the load files. As I said, we have the applications instances, blah, blah, blah. Privileges. Now, every security domain and application can have a basically bit mask of different privileges associated with it that define what it can or cannot do. Basically, something that is not explicitly enabled is not possible to do. The issuer security domain, basically as the root, can define which privileges a security domain, a supplementary security domain gets when it creates it, and a supplementary security domain can define which privileges an application that gets installed into it will get. Yeah, I don't have a list here of the privileges. I was thinking of copying it from the spec, but I didn't bother. But it's what kind of access it has to different parts of what can it do, authentication or different topics. So now GlobalPlatform and UICCs or USIMs. ETSI UICC specification does not mandate GlobalPlatform to be present on the card, so you can have a perfectly ETSI UICC compatible card that doesn't have GlobalPlatform. Also, 3GPP doesn't have a requirement. You can have a USIM that doesn't have any GlobalPlatform support. In reality, most, if not all, support at least parts of GlobalPlatform. And often at least the SCP-03 and SCP-80 is available even on older cards, and on modern cards normally SCP-81 is frequently found. This is this HTTP over TLS PSK. I'll talk about this in the OTA talk. What you also see is that contrary to, let's say, grown-up cryptographic smart cards used in the payment industry or something like this. In the telecom industry, you often only have symmetric cipher support, so no RSA, because, well, it's never used anywhere in GSM. So why would you need RSA hardware accelerators in the chip if there is no use case for this? So with eSIM and eUICCs, that changes slightly. So there we need elliptic curve in the eUICC. But then even there's no RSA, it's only elliptic curve, right? So the telecom industry always is very cost sensitive in terms of the per card costs, whereas in the cryptographic smart card industry, you don't really care so much about the cost of a card. So that's why the telecom industry always has only a very limited feature set, and as I said, the real crypto smart cards have a more complete feature set. The eUICCs now in the eSIM world, they are heavily based on GlobalPlatform. So it's impossible to have an eUICC that does not implement GlobalPlatform. And the entire security model is tied to the security domains. So we have already mentioned, we have the ECASD in the eSIM world is basically, as the name implies, a CASD. For eUICCs, we have two different flavors of issuer security domains. One is the ISDR, that is the root issuer security domain. The R is really for root. That is basically what the card issuer, the card manufacturer controls on the card. And then the currently active eSIM profile, the logical eSIM that you download on the card, there can only be one active at any given point in time. And the one that is active has its own ISDP. That's the issuer security domain of the profile. That's the P. That is controlled by the operator who issued that eSIM profile. So they can both basically have their own security domain in the card. And then we can have additional MNOSDs inside the ISDP. I'm not quite sure why this needs to be the case, but yeah, I mean, you can always have more supplementary security domains, but I mean, so the ISDP is from the operator and the MNOSD would be from the operator. I didn't really get why they suggest there should be two of them, but yeah. And then secure channel protocols have been adjusted for eSIM remote provisioning. So actually the eSIM download into the eUICC happens over a custom SCP-03 dialect. Originally it was called SCP-03, but then they diverged so much from SCP-03 that it created a lot of confusion, and I think now I think they call it the RSP protocol. I'm not sure. There's a different name now. So in the latest version of the spec, the name has been changed to sort of make it clear that it's not really SCP-03. And the authentication of the off-card entities with the ECASD works using elliptic curve public key crypto, and the encryption then actually uses AES, so authentication ECC certificates, and then you use ECKA, elliptic curve key agreement, to derive a symmetric key that you use for the actual encryption of the data there. Yeah, the ECASD holds the X509 certificates, at least in consumer eUICC. In machine-to-machine eUICC, it's different certificates which are not X509. Hold your breath. I have no clue why. They had to invent a new format. And the ECASD, ISDR, or ISDP may be configured for SCP03 access. So it is not mandatory by the spec, but of course, eUICC specs say, well, the card must support GlobalPlatform, and that means that the card issuer can, of course, enable or disable or whatever all of these features that GlobalPlatform has. So the normal remote access of like how you download eSIMs into an eUICC doesn't need SCP03 or something like that. But you can enable it, and you can enable it also for the ISDR. So you can actually, as an eUICC manufacturer, you can create quite interesting products where you can sort of remotely later on add additional root certificates to the ECASD of an eUICC, so that in the future it accepts eSIM profiles signed by a different entity at the time when the card was issued, and then you can do things like that, which may have interesting use cases. I'm very excited about that stuff, but that's just me. So, the specifications are all available on the globalplatform.org specs library. There's a very interesting click-through license agreement that you need to agree, which tells you you can use the information for anything you want. It's like, okay, great, yeah. Initially it says, well, yeah, you have to be bound, and there may be, if you have to pay some license fees, but all the specs, maybe they have one spec in there that you cannot download, but all of them that I've downloaded, certainly all of them relating to this stuff, you can just download it. If you read the details, basically, yeah, you can use it for whatever you want. So, okay. Good, so that's it for that. Now, we are almost out of time, but let me check what is the next talk in the schedule. Does somebody recall what's my printed schedule?
Yeah, it's my talk.
It's your talk. If it's okay, I would say let's do a more extended demo tonight at the USSE for those who are interested. Then I have a bit of time to prepare that. I mean, I can do all the commands, but I first have to check the keys for which card that I'm inserting and so on. It's a bit sad. Sorry for not preparing. Okay, so then we'll do that demo tonight. And Saprice can continue. So yeah, thanks. Maybe one or two questions if you have any. Yeah. Sorry, we're waiting for the microphone.
Okay, yeah. Okay, yeah, it's quick. So who's exactly behind GlobalPlatform? Like it's just some organization, standardizing organization, some cluster of companies, or do you know?
I didn't really check, but I mean, for sure, let's say all the major smart card OS vendors, I would say, and also as well the large application users like the payment industry and so on. So. It's that's what I would have suspected, but I didn't check the member list. I'm sure it's on the list, on the website. Yeah. So yeah, thanks.
You talked about SCP-02 and 03 and logical channels. So do I have a single logical channel over SCP-02, or can over the same SCP connection have multiple logical channels?
No, the logical channel is underneath it. So the logical channel you have at the APDU level that you talk to the smart card. And then you can create a logical channel, and in that logical channel you can establish the SCP, or you cannot. It's not necessarily connected. So it's a bit like you can establish a TCP connection to somewhere, and then you can choose to have TLS in it or not. That's sort of the analogy. Yeah, so I think Saprice had a question over there. So.
Is ARM is a security domain?
No, it's an application that lives in a security domain.
I see.
On a normal UICC USIM, it lives in the IST, in the issue security domain, for example. Okay, good. Then thanks everyone.